So today's class session is on Unit 1 assessments. You may notice in my math lab, so everyone should be able to see my screen. You will notice that there is this cumulative practice for Unit 1 would be ultimately your practice test for this Unit 1 assessment. I did want to go over a few things about it. So the assessment is not up yet. Of course, this is just practice. On a Wednesday at 6 a.m., that's when the link will appear for you to take it. So you can take the test at any time from Wednesday at 6 a.m. to Friday at 6 p.m. Take it on your own. You don't have to show me any scratch work. You don't have to, there's no proctoring at all. You take it on your own as if it were just some assignment. So you have Wednesday from 6 a.m. until Friday at 6 p.m. It is timed, so you have 70 minutes to do it. If you have time and a half, then that'll be 105 minutes. So if you do have your accommodation through me, if you show me your accommodations, then that will be applied as well. There's only 13 questions, which puts you at about a little over 5 minutes per question. So I don't think you will need 70 minutes, but it is there. And if you have 105 minutes to do it, then again, I don't think you need that much time. I look at the questions, some of them are fairly quick. So that means you'll have more time for other questions. So again, no scratch work is needed. You don't have to show me anything. You take this test on your own time. I have no involvement with this whatsoever. There's also, as you might have heard, there's no partial credit either. So that means you need to be very careful with your submissions, with your answer submissions. You need to make sure they are correct. It's just a department rule. So it's going to be an all or nothing thing. So that means no scratch work is needed, but you get to take it on your own. You get to use whatever resources you have available. Tech problems, if you have any issues with your computer dying on you mid-test or something like that, your internet is lousy or whatever the case may be, that cannot be accommodated. So if you're taking the test at a place where the internet is spotty, it may be kind of risky to take the test. So there's only, if you email me saying you're having a test issue, there might be a limited amount I can do about it. I might be able to help, but chances are I might not be able to. When is the test? You could take it 6 a.m. on Wednesday to 6 p.m. on Friday. So you can take it, again, it's not in class, you take it on your own. On class on Wednesday, I'm just gonna start talking about new stuff. So you take this test on your own, or assessment as they call it. So again, scratch work, don't need it. Tech problems, so just, since you have so much time to take the test, what amounts to 50-something hour time period to take the test, you need to take it on campus, then do so. So just make sure you take it in a place where your internet is reliable, what you're using is reliable. I'd recommend a desktop over a laptop, for example, so the thing doesn't die on you. And besides for that, yeah, it's going to cover everything we've covered in class, as well as, I guess that also segues into the email I sent out a few days ago. There is an additional video that you all have to watch on your own. It's an effort to stay caught up. So this video is on quadratic functions and their graphs. You may notice in the lecture links tab here, I have part 1 and 2. I think altogether it's about an hour long. So it's even less than a standard class period. So you have to watch that on your own, and the homework is due Tuesday for this. So if you notice, the homework is due Tuesday, and the quiz is Wednesday. To make up for this, I am having a homework review session at noon today. I have office hours until 3, so I'm happy to answer any questions up to that point. So I'll be going through more of those problems during the test review, during the Unit 1 assessment. So in the last class, I went through like 3 of them, so that should help as well. So, and I sent out a link for that homework review session. So there's a Google Meet link I sent out. And I guess one more thing is I updated the notes. Like I said, on Wednesday, I'm going to be talking about the test. You're not taking the test during class. In class on Wednesday, I will be moving on to the next material. If you notice at the end of the notes, I added chapter 2. And this is the stuff we'll be doing on Thursday, or Wednesday rather. And I'll update it probably later this week with everything else leading up to the midterm. I pretty much have it typed up. I just gotta check it one last time. But other than that, I think that is what I have before we go over the Unit 1 assessment. Does anyone have any questions for me before we begin? I also will be assigning more workbook pages due Friday. I'm trying not to assign any, but I will send out an email after class today specifying those. So doing the workbook problems will also be test review. Okay, so let's go ahead and get started. So I'm just gonna, for the review, I'm just gonna go through the cumulative practice for Unit 1 and talk about strategies for doing the problems. So start off with what I think is a fairly straightforward problem. In fact, we went through this problem in class. Yes. I'm sorry. Why didn't you guys tell me?
I was gonna let you know if we started writing.
Yeah, I don't think you were showing anything yet.
Are the workbook pages gonna be on my math phone?
So that's a good question about the workbook pages. Yeah, you have to have the workbook. You have to have it now. So you got to get it from the university bookstore, not the textbook rental place. The university bookstore.
Do you know how much it is?
15. Again, not my. I wouldn't voluntarily assign a workbook, but it's a department thing. So you got to get the book from the bookstore. I won't be typing it up. And I'll go over the problems. I'll email the problems after class today. Try to assign like 1 per page or something, and they're not a big deal to me. So let's move on. Again, let me check virtual. Cool. All right, so let's go ahead and start off. So first it wants us to type the linear equation that relates C to all this stuff here. So something about a word problem, and naturally it says linear equation, which instantly makes me think of mx plus b. They already have the y part. The y part, they're calling it c because this is a word problem and c means cost. So I'm just writing mx plus b. So that means naturally we need to figure out the slope and the y-intercept. Well, it starts off by giving us $35 plus 8 cents per mile. Now, when I see per mile, that makes me think of something that's changing. So naturally, I go up here, the way I can organize that, 0.08 for the slope, 35 for the y-intercept. The 0.08 per mile makes me think that, all right, so that's going to be a multiplication. 0.08 where x is mile. So that product is plus 35. So from here, it just wants us to plug in x is equal to 178 and x is equal to 450 into that function that we figured out. So it's important that you choose the correct formula because naturally the other two parts are based directly off of it. I'd rather focus on other problems because I think there's other ones that are a little bit more difficult. So I'm not going to do these, hoping you can plug those numbers in. So I assume everyone's good here. And for those of you at home, I might be erasing rather quickly, so you might want to get used to this idea of taking a screenshot of your screen. People in class, you can take out your phone and take a picture if you want. I don't mind. I'm also posting this online. Okay, I think this is a good one to talk about. So this is one of the problems that is on the video you have to watch. And so the situation here, I do give a rule of thumb for a problem like this, and I'll explain why in a second. So if anything, it talks about manufacturer, something about a dryer and revenue. What I care about is the function, which happens to be a quadratic. Why is it a quadratic? Because the largest power is 2. The largest exponent is 2. So that's a quadratic. This is stuff I explain in the video that you either have watched or will watch later. So it goes on to say, regarding this quadratic, something about maximizing the revenue and then finding the maximum revenue. Now, I give a rule of thumb for this. Maximize or minimize. Maximize, minimize a quadratic. Wish I could spell today. Try it again. Implies, use the vertex, or find the vertex rather. So again, this is something I explained in the video. I'm going to explain it here as well. So part of the review you might see in the video is stuff I will be going over here as well. So what is the vertex? The vertex is a point on a quadratic function that is either the minimum point if the shape is upwards. So there's a minimum point here, or it'd be the maximum point if it's faced downwards. The vertex will be that no matter which way it's shaped. You don't have to figure out the shape. It'll give you that vertex value no matter what. So it's an ordered pair. And so naturally, I use this notation, this V with a little X next to it. That just means the X coordinate of the vertex. So I don't have to write out X coordinate of vertex. So this is the X coordinate of the vertex. And what's the formula for that? It's negative B over 2A. That's in the video. Now, what is A and B referring to? Well, what it's referring to is the fact that you might have messed around with these numbers before if you've ever done the quadratic formula. It's actually the same A and B from the quadratic formula. So what they represent are the numbers from the quadratic. So notice -5 because that's the leading number, and then 10,000 for the next number. That's A and B. Just like if you were to apply the quadratic formula to this expression, you would have to find A, B, and C. Here's A and B. So it's -10,000 divided by 2 times -5. So if you could put all this in the calculator, or you can put it in one step at a time. And you should get 1,000. If you did not get 1,000, you put it in the calculator incorrectly. And please check your work. So you get 1,000, start off. That's actually going to be your first answer here, part A or the first part, whatever you may consider it as. This is the location of the maximum value, as it's called, the x-coordinate of the vertex. And now for the next part, we found the x-coordinate of the vertex, so naturally we're going to find the y-coordinate, or the maximum itself. So to figure out the y-coordinate, we take the value that we found in the previous step, and we plug it back into the function. That's it. So that was -5. We found 1,000. Let's see. I'm going to write this up here. So we're plugging in that 1,000 that we found in the previous step into every single variable. And that's just calculator work from here. -5 times 1,000 squared plus 10,000 times 1,000. Get a pretty large number, but that will be the answer here. So something to keep in mind, since this assessment is a one and done, as in there's no partial credit, something as minuscule as just putting in a bunch of zeros will be very important to keep track of. If you put an extra 0 or you lose a 0, you may have gotten the right answer, but the way this class works, it would mark that incorrect. So I'm just emphasizing, please be careful about the answers you input. But this is the typical strategy for a maximize, minimize problem if you were to see it on the test. Does anyone have any questions about this? Virtual people. I'll be going through more types of problems like this that come from that additional section. So we'll be seeing the stuff like this again. We did this one in class. I can come back to this one later if anyone requests it, but I want to focus on ones that we might not have gotten to. I think this one's pretty straightforward. Rather look at ones that are more complicated. Maximum minimum value, and we have a quadratic. This may be familiar. This is exactly what we did. This is the same exact problem. And again, problems like this will show up on that homework that's due Tuesday. I'm going to go over this one maybe a little bit quicker, but notice it's set up a little bit different. It's asking for whether the function has a minimum or a maximum value. And so the question is, how do we determine that? So something I have to add that we haven't talked about before is the shape of a quadratic. Again, I talk about this in the video, but here, it either is a cup that's shaped upwards or a cup that's shaped downwards. So how do we know which one is which? What's that? It is the leading coefficient. So the criteria is the sign of the leading coefficient that I'm underlining in red. If that number is positive, then it's shaped upwards. If it's negative, it's shaped downwards. Well, guess what? -3 is, well, it's negative. So because the leading number is negative, then the cup is shaped downwards. That's pretty much it. And so you might think, all right, cool, you found a shape. What does that tell us about maximum or minimum? Since it's shaped downwards, naturally we have a peak or a maximum. It's right here. So that's how you determine whether it is a maximum or a minimum value. Facing downwards, we'll have a max value. If it faced upwards, it would have a minimum value. And that's it. Just the leading coefficient tells you that. And then it wants to know the value of this. Now, I already said before, whenever you have a quadratic and you're finding the maximum or the minimum of it, something to do with the vertex. The vertex has two components, an x component and a y component. It wants to know the value. The value is a y value. Generally, when they say a value, they want you to find the y coordinate. So in order to figure out the y coordinate, we first need to figure out the x coordinate. You cannot find the y coordinate without the x coordinate. So we have to find the x coordinate first. It's -b over 2a. It's going to be minus -12 divided by 2 times -3. This is because a is -3 and b is -12. So I plugged in a and b appropriately. And so this is 12 divided by -6, which is -2. That's not the answer. Just because we did a sequence of steps doesn't mean that we have the final answer. Now we figure out the y coordinate of the vertex because it wants the value. So we take that -2 and we plug it back in. This is calculator work. That's 12. That would be our answer. So it's pretty much the same problem as before. It's just set up in a slightly different way. Does anyone have any questions about this one before we? So the value is determined by primarily the wording. So the wording, so the reason why we need to find the y value is because whenever you see value by itself, that implies a y value unless they specify. If they don't specify anything, then anytime they say value, they want a y coordinate. Sometimes they might say the value of the x, or the x value, and then that would tell you you find the x. But if it's value by itself, that's y coordinate, the y coordinate of the vertex in this case. So that is the criteria. That is sort of the context behind how to distinguish one from the other. To go ahead and erase. And let's move on. I think this is a good one. I would anticipate there being one domain problem on the test. So that means you need to know the criteria. So how do you determine the domain of a square root? Well, you take the square root. So the criteria I put in the notes is you want everything, I called it a radicand. You take everything under the square root, that's the radicand, everything under the square root, you set that greater than or equal to 0. And that is how you set this one up. For the domain, it was set the denominator not equal to 0. For square roots, it's set the radicand greater than or equal to 0. Algebraically, we can solve for that fairly quickly. I don't think that should be too much of a hassle. But we're not done, because they want us to put the answer in interval notation. And as such, we need to take this value here, or this interval of values, and figure out how this translates. So I plot 6 because 6 is part of our inequality. We are including 6 because there's an equal to sign, and we want to be larger than 6 as well. So values larger than 6, 7, 8, 9, 10, stuff on this side. The illustration here helps us determine that we would put a bracket on the 6, because 6 is included, and it goes to the right to infinity, which always has a parenthesis. And that would be the answer. That is the domain.
So you would always put it greater than or equal to 0?
For a square root, yes. For square root, you always put greater than or equal to. That's just the rule for square roots. Yes, if you, at any point, if you ever multiply or divide by a negative, you have to flip the inequality sign. So that is still true. So, with that being said, this. And if you're into hotkeys, \INF, just give you the infinity sign. It tells you if you hover your cursor over the symbol. Are you able to see? So if you're into hotkeys, you can utilize those. Okay, so any questions? If not, I'm going to go ahead and find other problems to do. I think this one's pretty straightforward. I think this one's a little bit more fair to look at because there was something mentioned in class about using the exponents to determine whether something is even or odd. But what about if there's an absolute value? So if you didn't have an absolute value, the pattern would normally be if all the exponents were odd, and there's a good chance you have an odd function. If all the exponents were even, guess what? There's a good chance you have an even function. But an absolute value, what is that? Because this absolute value here has an exponent of 1, just 7x. But it's even. It is an even function by chance. So what I'm saying all this for is that if you're going to use a patternized way of answering these, then you might want to consider the cases or do it the safe way, the algebraic way. So if you were to do it the patternized way, this would be even, this would be odd, because the exponent's 1. And if you have a mix, then your answer is going to be neither, because they have to either all be odd or all be even. But I'm going to explain it the algebraic way, which means we would start off trying to find even. So this would be the safe way. But if you get to the test and you completely blank and you have no idea, then at least you have some way to help you out. And you got a 33% chance anyways by the nature of the selections. So remember, for even, you exchange every x with a negative x. And you work out the problem. So 9 times negative x is negative 9x. And since there's a negative within the absolute value bars, let me just, by that mere virtue of coexisting, the negative sign pretty much gets booted. That's what absolute value means. It means anytime you multiply by a negative, get rid of the negative. Just no matter what. So it's gone. Didn't even have to do anything with it. And then we ask ourselves, is this the original function? It is not the original function. Because all of a sudden there's a negative on the 9x. So it's not even. All right, what about odd? So now we have a 50-50 chance. What odd says is put a negative sign in front of the exact result we got before. So the exact result we got before was this one. And so the thought process is, all right, that form wasn't good enough. All right, let's just put a giant negative sign in front of the whole thing and try again. So that's what I did. put a giant negative sign in front of the whole thing and try again. And now is this equal to the original? It is not. Of course, now there's a minus sign in front of the absolute value bars, which should not be there for this to be odd. So naturally, it's not even, it's not odd, it's neither. That's the algebraic approach. You can try the pattern approach as well, but pretty much do it at your own risk. Does anyone have any questions about this before I move on? If not, I'm going to go ahead and erase all of this. And let's move on. I think this is a good problem to do. So this is a problem that will be off of the homework that's due tomorrow. I'm going to go through it anyways, but my video also explains this process as well. And what it does is, well, it starts off by wanting us to graph this quadratic function. So this is a quadratic function because the highest degree or the highest power is 2. So naturally, when we go to plot this thing, I would want to select the vertical parabola tool. So just a parabola, that's what we're looking for. And if I were to interact with this graph in any way, notice it wants us, it doesn't have that rectangular box that comes up that says, determine the vertical stretch, move the slider for the vertical shift. It doesn't have that box that shows up. Now it's just this junk. So by kind of foreshadowing what I'm looking for, I do not have to determine the vertical stretch or compression. I don't have to determine the shifting of any sorts. I need to figure out the vertex. And this isn't the graph, by the way. I have to figure out the vertex, whatever it may be, and any other point on the graph, any other point at all. I don't know where that point's at. We're going to figure that out in a bit. But notice as soon as we pick that second point after the vertex, they will do everything else. So I don't know what the graph is, so that's what we have to figure out. So the first thing we have to figure out is the vertex. So let's go ahead and figure out the vertex. So the vertex, I'll do that over here. So the vertex, there's an x-coordinate and a y-coordinate. And the x-coordinate is found by negative b over 2a. What is a and b? A is understood to be 1. There's no number up there, so it's understood to be 1, positive 1. And b is equal to negative 4. So A is 1, B is negative 4. Really, C is negative 5, but we don't need a C. So now this is minus negative 4 divided by 2 times 1, which is 4 over 2, which is 2. So we have the x-coordinate of the vertex. Now we need to figure out the y-coordinate of the vertex. To figure out the y coordinate of the vertex, we have to plug the x coordinate back into the function. So now it's 2 squared minus 4 times 2 minus 5. So just a bunch of calculator work. We get -9. So for the vertex, in fact, I'm going to put this up top. So the vertex is a point, and that point is 2, -9. But we haven't really solved for anything yet. We found the vertex, I mean, cool, but we haven't graphed anything yet. If anything, when we go to graph this, we know the first point to plot, the vertex. But we need a second point. Normally for the second point, I like to find the y-intercept. It's just a very easy point. All we need is any other point. Normally the y-intercept is a good point to find. How do you find the y-intercept? You set x equal to 0. And so pretty much everything zeroes out. And so we get 0, -5 for the second point. So now we have the vertex as the first point. We have the y-intercept as the second point. And now we can plot those two to get the graph. So this may be kind of clunky. We want the shape of the cup facing upwards. The vertex is 2, -9. And then the y value is 0, -5. I want to kind of be clear about something. Let me clear that and then input that again. Because these grid lines are really close to each other. They're very closely stacked. So I've seen it happen a lot of times. You go to click a point and your mouse might move over one space and then it ruins the whole problem. Make sure you put your graph in the right spot. There is something in the top right that will tell you where your point's at. So you may notice up here, that will tell you where your point's at. And here, like I said, it was 2, -9, so I can look at that top point up there and see that it does in fact say 2, -9. So some people don't notice that. And then 0, -5 for the y-intercept. It does say 0, -5 in the top right. So I know that that is the point that I want to select. And I can save it from there. So we're not done yet, but does anyone have any questions so far? So we can, now that we have the graph, we can figure out the domain and the range. So the domain and the range. So this graph does not put arrows like I do. So we have to be smart about this. The domain is the furthest to the left versus the furthest to the right. And we see that in both directions, it goes on infinitely. So the domain is going to be all real numbers. For the range, what's the furthest down we can go? Seems to be right here, which happens to be the vertex, which was 2, -9. But we're looking for the range. The range only cares about y values. So naturally, we only look at the -9. So for the range, we include the 9, points included, and the highest up we can go is to infinity. That would be the domain and the range. And before we move on to the last stuff, we'll erase the stuff on the second point. And we'll look for increasing and decreasing, and then we'll be done. So, where's the function increasing? Well, you can think about increasing and decreasing like a roller coaster. So, when are you increasing in altitude? I'm going to do this in blue. You would start at the vertex, and you would go all the way up. And naturally, this would be a horrendous roller coaster because you increase in altitude forever. So, that interval that I just highlighted in blue here, increasing and decreasing, you never use brackets, and you use the x values to denote them. So now we're going to use the 2 to represent the leftmost part of the increasing region. So we never use brackets, so we're always going to use parentheses. So I can just set that up right now. 2 is where we start increasing. And we increase infinitely. This goes to the right forever. Decreasing starts all the way over here, goes down all the way to the vertex. So naturally, this will be negative infinity to 2. So there will be quite a few problems like this on your homework that's due Tuesday that asks you to go through the same exact process. So the same exact process. You will be doing stuff just like this. Maybe give or take, increasing, decreasing. Maybe they might add 1 or 2 extra things, but it'll pretty much be formatted just like this. So you will be doing this several times. Does anyone have any questions before we continue? Online people, anything? If not, let's go ahead and erase all of this and move on. I'm going to skip this one. We did this one in class. Maybe come back to that one. I think this is a type of problem you should be familiar with. Something that asks you to take some regular function like the square root of x and shift it to the left 3 units. Oops. So to go left or right, That means that you have to add or subtract the x value directly. So that means this number would need to be in the square root to go left 3, add 3, because it has to be the opposite when you go left or right. So it definitely may be good to familiarize yourself with problems of this caliber that may ask for just one direction, maybe 2 or more. Maybe they would want you to shift to the left 3 and then up 4, for example. Or maybe they would want you to reflect about the x or y axis by chance. I think one of the workbook questions is a good job of this. One of the ones I'm assigning is number 4 from page 5 of the workbook. I think that would be another good problem to familiarize yourself with. Does anyone have anything? No. So this is another one off of that homework due tomorrow. And if we enlarge the graph, well, as you can see, my mouse gave up. All right, it's working. Okay, sorry about that. So if we preface this, we would need to determine that, well, we need to know what the shape of this is. And since there is a square as the highest power, that means we would pick the x squared tool, the cup shape. Now, by interacting with the graph, it doesn't ask us to find 2 points, but rather that box comes up and we have to figure out all the various characteristics, the vertical stretch, the shifts, and any possible reflections. So this is a problem we need to most likely be familiar with in anticipation for the test. I'll start off with the vertical stretch and compression. Vertical stretch and compression. This comes about whenever we multiply a number to the function. The only number that I see that's multiplying is 2. So naturally, I put 2. There's also vertical shifting. The vertical shift, if you move the slider, if you forget which one vertical shift is, if it's up, down, or left, right, if you move the slider on the interactive thing, you will find out very quickly that it's up or down. So that's a good way to remember. This is going up or down, which is determined by a number that is adding or subtracting to the function directly, or the function directly, and not the x variable. This is also a verbatim operation, which means that if we subtract 4, that means we are going down 4. And then finally, there's the horizontal shift. which is whenever we add or subtract to the x variable directly. So it's x plus 1. So naturally, we want to go opposite of this operation. So after we have all of that, we can fill in all the answer choices. One's 2, vertical shift of 4, and a horizontal shift of -1. It does everything for us. And from here, we can figure out the domain and the range, now that we have the graph. Domain is left to right. So left to right is -infinity to +infinity because it's arrows on both sides. Range. The lowest point here seems to be the ordered pair of -1 to 4. And since we're looking for the range, it's going to be 4 as our lowest point. Four is included because that vertex is part of the graph. And then we go up forever. So that's +infinity. And we're done. Does anyone have any questions up to this point? Well, let's move on. This one should be a quick one. The answer is yes, simply because y does not have a square on it. That's it. So that'd be a quick one. So this is a good one as well. I do talk about this one in the video, but I'll go ahead and do it here as another problem. So they give us the vertex and some other point on the graph, which is interesting because we've done problems where we build the graph of the function after we find the vertex and any other point on the graph. So in essence, we're working a bit backwards. So with that being said, there is, as I mentioned in the video, there's a vertex formula. Or a form, a vertex form. And this is a x minus h squared plus k. And hk, h is the x coordinate of the vertex. K is the k coordinate of the vertex. And this is that vertex form. So if anything, I'm just going to put this in as a placeholder. And we're going to slowly figure out what A, H, and K are. So, if anything, two of these values come to us very quickly. The vertex. There's H and there's K. They just give it to us. So we already have it. So now our vertex form we can now plug in 3 for H and -4 for K. because that comes directly from the vertex. So we can come directly over here and update our answer as such. But we're not done, because we now have to find A. And once we find A, then we're done. So how do we find A? Well, that's when we utilize this unused bit of information over here, the extra point that they give us. What it does is it gives us a temporary X and Y value we can plug in to solve for A. So this would be scratch work off to the side. So now we have -1 is equal to A, 2 minus 3 squared minus 4. I plugged in 2 for X and -1 for Y. And now we just follow order of operations and do some simple algebra. Two minus 3 is -1. -1 squared is +1. A times 1 is A. Add 4 on both sides. And we just get that A is 3. So that is the final piece of the puzzle. That's it. We plugged in a temporary X and Y value off to the side to figure out A. And that's what we did. We found A was 3, so then we go back to X and Y. I do another example like this in the video, but it's the same exact process, Does anyone have any questions before I move on? If not, I'm going to do exactly that. Pretty much what this problem says is be familiar with your library of functions. So we have a whole page. There's a whole page where all of these shapes are provided along with their names. And you would come right here and start moving them to their appropriate places. So it's, again, I'm going through this quickly because you have a whole page that gives you all of these. But in other words, just make sure you have that page accessible for your test. I wouldn't imagine it would take you over 5 minutes to do a problem like this. So I'm going to breeze past that. Right. This is one I want to do, but I want to change it up. We're going to ignore all of this. It's going to be a perpendicular problem. So this is a perpendicular problem. We haven't done one like this yet. So I wanted to go through one like this. So for a perpendicular problem, so when I explained in class, for perpendicular, as soon as you see that word, what you should think is take the negative reciprocal of the old slope. So what is the old slope? The old slope, well, it's convenient that the original line that they give us is in mx plus b form, which means we can determine the slope and the y-intercept very quickly. In particular, the old slope is 1/2. So now we have to take the negative reciprocal of that. Reciprocal means flip. So 1/2 flipped is just 2. And then negative means you flip the sign. If it were positive, you would make it negative. Negative, make it positive. So now this is the slope of the perpendicular line. So now we already have half of the final answer, because the perpendicular line is indeed just a line. The answer will be formatted as y is equal to mx plus b. We do have to contain y equals as part of the notation because they want an equation. Texting person, do you see the necessity for an equal sign given the criteria here? I want to emphasize that because I know you all would be able to get it correct, but the nitpicky stuff is that's, I'm trying to emphasize that. And also a good indication for you to flip your phone over. There you go. So we figured out that the slope is -2. And now we have to figure out the y-intercept. Well, I don't see the y-intercept. We have the slope and we have a point. Well, we can use point slope. The point slope form. And just as a reminder, here it is. We can use this form because we have a point and the slope. So let's go ahead and plug everything in and then put this into slope-intercept form, and we'll be done. So it's just a little bit of algebra. We did a distribution here. The minus -1 is a +1. And combine like terms, the 1 and the 4, subtract 1 on both sides to get that +3, and that's the final answer. And that would be the step-by-step process for a perpendicular line. So then we can come up here to our final form and replace the b with a 3. So this would be our final answer up here. Does anyone have any questions about this one? Finish off with only a few parts of this one here. I just want to do parts F, G, and H for this problem. So we'll start off with F here. And it wants us to determine for which values is the function greater than 0. When the function is greater than 0, that is when this graph is above the x-axis. So there's 2 segments. But we're going to put open circle at every place where the graph hits the x-axis. And this is primarily because we are just simply greater than 0. Since we're finding a compound inequality, we will first find, in either this case or the case with interval notation, you find the leftmost x value, the rightmost x value. And we put it as a compound inequality, where we do not put equal to signs because we are simply looking for when the function is greater than 0, not greater than or equal to. We will use a comma and then refer to this segment over here. The leftmost x value is 12 and the rightmost x value is 18. We exclude 12, but we include 18. This is the only reason why I did this problem. We include 18 because I do not have an open circle next to it. I didn't need to. It wasn't intersecting the x-axis. The 18 is all strung up here by itself, which means it would be included. So that's why the 18 gets an equal to component, but the rest of them do not. Simply because that 18 is not on the x-axis. I think that was the main one I've gotten a few questions about. So if you have questions about the other 2, I'll explain those afterwards, but I'll pretty much wrap it up here. In class people, do you have any questions? If not, feel free to bounce. Virtual people, answer any questions you may have.